Does the universe have an edge? Is there a final frontier? A cosmic wall beyond which there is nothing? This question has fascinated thinkers for millennia and challenges our understanding of space and time. We're used to boundaries. Rooms have walls, islands have shorelines, planets have atmospheres. But the universe isn't a box sitting in a larger space. By definition, it's everything. All space, all time, all matter and energy. To ask about its edge is to question the very nature of reality. Scientists use powerful telescopes and mathematics to probe this mystery, and the answers are far stranger than a simple yes or no. The universe's shape, the echoes of the Big Bang, and the limits of our perception all play a role. The quest for an edge is really a quest to understand the rules that govern existence. We'll explore what science reveals about this ultimate question. Is the universe finite or infinite? Does it have an edge or is it boundless? To find out, we must let go of everyday intuition and embrace the vastness of the cosmos. The universe is stranger and more beautiful than we can imagine. Its secrets are waiting to be uncovered. Let's begin our journey. Before we ask about an edge, we need to define the universe. The universe is everything: all stars, galaxies, planets, dust, gas, and the space between. It also includes the fundamental forces and time itself. Space and time are woven together into space-time, a concept from Einstein's general relativity. Massive objects curve space-time, creating gravity and shaping the cosmos. The universe isn't a static stage. It's the dynamic, evolving stage, and the actors combined. Our universe began about 13.8 billion years ago with the Big Bang. Not an explosion in space, but the birth of space and time. Since then, the universe has been expanding, with every galaxy moving away from every other. The Big Bang happened everywhere at once, creating all of space. There's no center to this expansion. Every observer sees themselves at the center. This lack of a central point complicates the idea of an edge. The universe's geometry may be very different from our everyday experience. Understanding expansion is key to the edge question. If there's no center, what would an edge even mean? Let's look at what we can actually observe. There's a limit to how far we can see the observable universe. This isn't due to telescope power, but because the universe has a finite age and light travels at a finite speed. When we look at distant galaxies, we see them as they were billions of years ago. Light from the farthest objects has traveled nearly 13.8 billion years to reach us. This defines a sphere around us, the observable universe bounded by the cosmic light horizon. It's a boundary of information, not a physical wall. Every observer anywhere has their own observable universe. The edge of what we see is not the edge of the universe itself. Beyond our horizon, there's likely more universe, more galaxies, more stars. There's no evidence the universe stops at what we can see. The whole universe is almost certainly much larger than our observable bubble. It could be hundreds, trillions, or even infinitely times larger. But what about the universe's actual shape? The universe's shape is about its overall curvature. According to Einstein, space-time can be flat, positively curved, like a sphere, or negatively curved, like a saddle. The shape depends on the universe's total density. Current measurements suggest the universe is very close to flat. If it's perfectly flat and infinite, there's no edge or end. But there's another possibility, a finite universe with no edge. Imagine a two-dimensional creature on a sphere's surface. It can travel forever without finding a boundary. Our universe could be the three-dimensional surface of a four-dimensional hypersphere. In this case, the universe is finite but unbounded. Travel far enough, and you return to your starting point. There's no center, no edge. Every point is equivalent. This model avoids the paradox of a boundary. The universe could be finite in size, yet have no edge at all. The shape and topology of the universe are key to this mystery, but how can we visualize such strange ideas? Visualizing these concepts is tough. Our brains aren't built for higher dimensional geometry. Analogies help imagine an ant on a balloon's surface. The ant never finds an edge, and as the balloon inflates, every point moves away from every other. This mirrors our expanding universe. The Big Bang wasn't an explosion on the balloon, but the balloon itself inflating from a tiny point. The center of expansion isn't on the surface, it's in a higher dimension the ant can't access. Similarly, our universe's expansion has no center within our space. Another analogy, a video game where leaving one edge of the screen brings you back from the opposite side, a torus topology. Our universe could be flat but wrapped around itself, so traveling far enough brings you back to your starting point. These analogies show how a universe can be finite yet unbounded. There may be no outside to the universe at all. The true shape could be even stranger than we imagine. Our best models are still just approximations. What do we actually know for sure? We know the universe is expanding, as seen in the redshift of distant galaxies. The Big Bang happened about 13.8 billion years ago, and the observable universe is about 93 billion light-years across. The universe is remarkably uniform on large scales, homogeneous and isotropic. Measurements suggest it's very close to flat, but we can't be certain if it's infinite or just extremely large. There could be a slight curvature too small to detect. If so, the universe might be finite and unbounded, like a hypersphere. The universe's topology, how it's connected, remains a mystery. It could be flat and infinite or flat and wrapped around itself. The biggest unknowns are dark matter and dark energy, making up about 95% of the universe's energy. Dark matter holds galaxies together. Dark energy accelerates expansion. We don't know what they are, and they could reshape our understanding of the universe's fate and geometry. The true nature of the cosmos is still at the frontier of science. But what about the edge? So, does the universe have an edge? The scientific consensus is no. There's no evidence for a physical boundary where space-time stops. The only edge we know is the edge of our observable universe, a horizon of information, not a wall. Beyond it, there's likely more universe, stretching on and on. The universe may be infinite or finite, but unbounded. No wall, no end. This elegant solution removes the paradox of what lies beyond an edge. The real edge is the limit of our knowledge. Mysteries like dark matter, dark energy, and the universe's fate remain unsolved. With every discovery, we push the edge of understanding further. The universe is magnificent, boundless, and beautiful. Our journey of discovery is far from over.